Wojtek Biela. This is my colleague Krzystof Jelski. We're from a company Executable from Poland, based in Warsaw. And we're going to talk about executable documentation, how we come to set the project up around acceptance tests, what we try to do with them. Some of the things we'll be talking about are the things we want to do, not that we already are really good at it, but we're sharing our experiences, our thoughts, and not only our thoughts. Most of the thoughts are from the Agile community. We just try to adapt them to our specific context, to our problems. First, I would like to know who is here, so I'll do a 2-minute survey. I'll just... No? Those are roles: programmer, tester, manager, QA, and client analyst. And I would like you to raise hands, everyone that sometimes is in the role of a programmer. Please, raise your hands. I would like to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. 1, 2, 3, 4. 10. Good. Now, who in here sometimes is in the role of a tester? 1, 2, 3, 4, 5, 6. 6 testers. Managers. I knew that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah, right. QA.
What is exactly QA?
Quality assurance. And a half, 5, 6. 6. Client. I knew you were one, but you're the only one. Okay. Analyst. 1, 2, 3, 4, 5, 6, 7, 8. 8 analysts. Okay. Well, that's a bit biased, but but true. Okay. Good. We divided this presentation. Yeah. We divided this presentation into 3 parts. First, I'm going to introduce documentation, acceptance tests, to talk about this a little. Then we're going to show stuff, show some tools that we test with, that we do acceptance testing with, and show a web-based app that we test and a rich client app that we have tested. Then I'm going to talk a little about setting up the project, a little about infrastructure, and more about relationships with the client and stuff. So now for the intro. Well, yeah, many people do misread those books. I myself did when I read Ken's Beck first book on XP and didn't read it really well. Just glanced through it and said, well, then now away with everything. We're just rolling, and that's when you will stop using any models, stop documenting, and that's when things are starting to get ugly. So documentation, well, yes, it's a good thing. We need that, and we need to embrace it. We need to make it good. We'll just not fall into the traps of waterfall, but it's a good thing.
Why?
Why? We're going to talk about that later. Well, and yes, when we talk about documentation, I mean, well, there's a world beyond Microsoft Word or any other word processor on the other end, and heavyweight design tools, case tools that will have a strict process of modeling, documenting. There's a really big world out there, and well, to see that world, read Scott's web pages, and you'll see it. At this point, we had this presentation. It was a workshop a few months ago. We did a brainstorm, and we don't have time for that now, so I'll just present the result of that brainstorm. What is the purpose of documentation? Why we need documentation? Yeah? We need it because we want communication to be in some non-transient form. We want to ensure somehow good quality. We want unambiguity. We wanted to help introduce new people to the project. That is, to have knowledge transfer, to analyze problems, to help us think the problems through, to have a point of reference, so that we can verify if what we're doing is what the client ordered. Well, we also need it for marketing purposes. Internal, because we need to fund the project, we need to make everyone happy on the different levels of the company. And external, well, we need to advertise ourselves to other clients in different ways. Well, we also need to feel safe. We need to plan, and many people don't talk about that. We need a legal agreement, and many times the documentation is the thing that it's thrown around when we do that agreement, some kind of contract. I don't want to discuss this. It's a result of a brainstorm, so I don't want to say if it's good or bad. Those are the things why we as a collective think that we need documentation. Now, so what are the attributes that a good documentation should have? That was another brainstorm, and I'll present it. Well, it should be verifiable. It should be fitting the target audience that it's written to. It should be unambiguous. It should be up to date. It should be brief, not 1,000 pages long. It should be easy to maintain, as we know the scope and everything changes in the project. It should be accessible for everyone. Well organized, especially when there are dependencies between modules and stuff. It should be adapted to our current project, the way the client talks to us, how the team is co-located or not, and stuff. And it should be complete. Things that we do that are not in the documentation should not be done. So, do Word documents or UML diagrams themselves are by design not safe. We cannot verify them. They do not have many of those attributes. From the other side, yes, the acceptance tests that we'll be talking about don't have all of those attributes, but we're talking that they have a really large set of them. So, what are the kinds of acceptance tests? This is a short intro. I have to keep myself short. Please keep me short. Manual tests, just click through. Yeah? Yourself. Every time you want to test, you need to test. Record playback tests. So now I said record, do something, and then playback. Domain-driven test. That's the subject we'll be talking about. Tests done up front, well, not necessarily, but good if they're done up front, and automated. Now, another dimension of kinds of tests. Tests may be done through the GUI, both web-based and rich clients. They may be done through the controller. If you have a VC pattern adopted or something of that sort, you go just below the GUI and test everything below, the database, blah, 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 without the GUI itself. Or through the model. There are more kind of integration tests, system tests, but yeah, that's, some people also call them acceptance tests. On some level, they may be thought of. So, what we think, not only we think, the best practice for GUIs, controllers, is to have a good architecture. Yeah. Think through the architecture first, of course. It's a bit, yeah, it's historically, first, if I'm wrong, please correct me, but I think that first came Martin's Fowler model view presenter. Well, before there was MVC, of course, but model view presenter. Now he has refactored it into passive view. Then Michael Feathers came with a humble dialog box, and then came I don't remember the company name that did it, but they had an article at Agile 2006 presenting a technique called presenter first. And we'll be showing this, well, we'll be showing some piece of code that has been done using this technique. Why do we need to test, to do acceptance testing? Because we need to secure regression. We need to know when to stop, when to stop the development. Because generally we need to deliver by features, not by tasks or anything else. We need to prove that our code, the things we've done, works. Or we need to prove it back that it doesn't work. Yeah? It's equally important to know that something doesn't work. Now a disclaimer, because I hear people talking a lot of acceptance tests and many times mixing things. Acceptance tests are not unit tests. They're not integration tests, they're not system tests, not performance tests. They're acceptance tests. So that's different things. It's important to recognize that. So, acceptance tests, for us, we try to use them as a platform on which we communicate with the client. Just like we used to use documents to do that, now we try to do the same using acceptance tests. But they become documents if you don't run them, if you don't execute them. So they only make sense if you really execute them, because there is some upfront, and not only upfront, but there is a investment in acceptance tests. So to let this investment return, you need to run those tests. Otherwise, they just become old documents. Well, yes, not everything's testable, and that's true. People many times tell me that they have a case that, well, they can't test that. Well, I say, so what? So test all the other things, probably 95% of the things that you have there that you can test, and do, for those things, do manual tests, or think harder. Maybe you can test that, you're just not that smart yet. Ask a discussion group about that. But, well, yeah, it's not a showstopper. Yeah? And, of course, use your mind. Not everything needs to be automated. I mean, stay pragmatic. If automating this little test takes you 2 weeks and the project is 4 weeks long, then come on. Yeah? So not to be try not to be religious about that, just use your head. Okay, I was really fast, I think. Good. Okay, so now for the demo. If there are questions to the things I talked about, I would gladly talk about this after the presentation, if there are any. Yeah. Demo. First introduction for the demo. The tools. I'll just explain some of the tools for acceptance tests. For internet applications, for web apps, we have used successfully both Selenium and Kanu web tests. They're very different. Selenium runs in a browser. It's really good. I like it very much, although it doesn't handle frames. It's sad, but it doesn't. Kanu web test, on the other hand, it doesn't run through a browser. It uses Rhino, a Mozilla implementation of JavaScript to emulate all the JavaScript that, well, not emulate, to execute the JavaScripts that are on a page, and it uses HTML unit to execute tests, and tests written in Kanu web tests. It's an extension of Ant, Kanu web test, and Selenium. Well, I hope you know Selenium. I have to introduce that. Rich client apps. We use a combination of things. Well, yes, we use fitness. Fitness is a really big subject. I'll talk about it afterwards. We integrate fitness with unit forms. If we use C# or any, C#, or if we use Java, then we use Abbot or JFC unit, Gemi. All are good. I mean, those are really nice frameworks for executing code on GUIs, and you're able to test the clients with them. Actually, and unit forms, actually, you don't even need source code for the application you need to test. You need the DLL, and it hooks into that, so you can test legacy apps with it. So if you have a project that uses some legacy components that are written in the .NET, then and you can't change them. They're third-party components, for example, and you want to test them. It's possible. Yeah, it's not a showstopper. And combining tools. It's really important to know how to put them together to get the best of it. This topic is quite fresh. You can read about that on many blogs. If you just type into Google acceptance testing, combining tools, Selenium, fitness, then you'll find many blogs on how to plug those things together to make them work. And it's really important to do that, because all those tools have their limitations, and if you combine them together, you get across many of those limitations and get more out of them. So what we're going to show first is an example of a rich client application. It's a real world B2B application, but we have re-implemented it. It was originally in, well, we have re-implemented only the part that we're showing, not the whole app, because it's a big system. So it was written in .NET, and for this presentation we wanted to do it again, and we have written it in Java using Swing. Actually, I've written down fitness because that's what we wanted to do, but we ran out of time. We had some other problems, and we ran out of time to integrate that with fitness, so I'm sorry, we're not going to show that, but we're going to tell you how to do that. We're going to show other examples with fitness, don't worry. And we use the presenter first technique to do that. Yeah, maybe we'll
switch for a moment. Okay, so about this application.
Oh, no.
While Wojtek gets it ready, I'll tell you about the MVP pattern. So we've got three layers. It's presenter, view, and model. So this is the pattern that was introduced in the paper Wojtek mentioned at Agile conference. And it works in that way that we don't want any GUI logic in the view. We just want the view to be damn simple, and the logic goes into the presenter. So the presenter just intercepts events from the view and perhaps from the model. Well, the model is the rest of the application. Not only, I know, Java objects or some data access objects, but the rest of the app. And here is the logic of the GUI. Okay, so perhaps first show how the app works.
Yeah.
To get the feeling of.
Yeah. First, I'm gonna run it and then talk about it. You talk about it. You have the mic.
Okay. So this is one form from our application, which allows to search for a participant, and the domain is. So a participant has some registers and customers. You can search by entering a participant number. It's unique number, so you always get one participant. Or you can search by customer name.
Yeah, the domain is it's an app for a trust fund agent that they use to sell funds. So they sell funds to customers, but customers are real people, and customers are and participants are.
This is the present.
Yeah, well, they could be just real people. If I come to a trust fund agent and say I want to buy something, then I'll be a participant. But a company, if it comes, then the participant is a company, and customers are representatives of the company, for example, that well work for them. So there's one participant, and one participant could have many customers. So, and registers are the bank accounts in that trust fund that I have, well, some funds. So participant has registers and participant has customers. Many customers could be in many participants. Yeah, that's mainly the model.
Okay, so we can. It's quite simple. We can just enter a number, hit the search button, and get the list of get the participant with that number. And if we switch to the other tab, we can see customers that this participant has. And the other possibility is to enter not the participant number, but part of the name of the customer, and we get a list of the customers. Okay. So this is what the functionality we implemented is. And the code. Well, the interesting part is the presenter. Could you please maximize this? Okay. So the presenter knows both the model and the view. It gets them right here. And the presenter subscribes to the events of the view to react to them. And here, a little bit, so here we've got the logic which handles, for example, starting the search. So after hitting the search button, this code gets executed, and this code talks to the view. It gets the number that the user entered, and well, it checks what to do next. What's important, in the view there's no logic. The view doesn't know participants, that there is something like participant or a register or customer. It's just, it knows only about the GUI elements, so the text boxes, tables, and so on. Okay, and please could you show the interface of the view? Okay, so that's the interface the view has, and just as I said, it doesn't have any references to our model. It just knows about tables and strings, you know, some basic stuff. And why is it useful for acceptance tests and tools such as Selenium? What we can do is to implement this interface in a fitness. I'm sorry, not Selenium. Fitness. We can implement this interface in a fitness fixture, and in that way we don't have to know anything about. I'm sorry, we don't have to test through the GUI. Yes, we can run it without any GUI. Okay, so.
Yeah, and what's important that just as my colleagues said, if we do it in fitness, we exchange the view that we have written that extends a JPanel. Could you show that JPanel? That, for example, it's a panel that implements the view, and it doesn't have any logic because all the logic is in the presenter. So yes, we are omitting some code while we're running it through fitness because we have an other view, but all the important stuff, the logic, how we change what's visible, which table is visible, that if you have a participant, then its clients are shown on the other table and their registers are shown. All that logic is in the presenter. So it gets executed both in our unit tests and in the acceptance tests with the model and database and everything. So we make this is the way we make the GUI really thin. So we can slice it off and let test through fitness. So yeah, so we have another view here. That's a view for, it says fitness view. So fitness comes here, and the only thing that's not tested is this part. And so to feel safe, we try to make it as small and as not important as possible. So we swipe. So using the presenter first technique, or using the humble dialog box, or earlier the passive view, model view presenter. Yeah, we come to this architecture that all the logic is in classes that are testable, both unit testable and acceptance testable, without touching the GUI. Why not touch the GUI? Because tests running through the GUI, and we're going to see that in a moment, are slow. So if we have a big system that has a lot of screens and things are going on, running tests, there are hundreds of them, will take on hours. Yeah? And we want to run them frequently and see the results fast. So if we want to keep it short, then we have to keep our tests running short. Yeah. So we could have those tests running through the GUI, of course, yes, but we would run them once a day or once a week because it takes a lot of time. But we need tests that will tell us every hour that we are on track and we didn't break anything. This is a web app. It's also a real-world application, and it's as is. We didn't rewrite it. I'll show you it as is. It's written in Java, in Spring MVC, and it's a web app, so it uses Selenium and it uses fitness. And what we've done here, I guided the programmer that did this app. She wrote a DSL for this particular client, for this particular project to construct those tests. So could you show it? I'm wondering if everything is running. We need to start the server. The server is here. Yeah, started. Okay, something's running on that same port. Wait, just a sec. This one. Yeah. Could you see? Okay. Okay. So first we'll run the test, then I'm gonna talk about it. It will take some time. Most of the time will be and we're gonna hopefully see the tests running. This is fitness, by the way. I'm gonna get back to that in a minute. Tests are running. So now he's done with the unit tests. Well, not the fitness tests that are done without the GUI, and now he's running tests through Selenium, but they're initiated by fitness. So you can see now we're not touching anything. Yeah, fitness is executing tests through Selenium, telling him to. Is text present? Click here, right here, push this button, do this, do that, and it's executing all those tests. Open that page, check this text. And I comment on the contents in a minute.
What is the role to use Selenium? Why do you use the Selenium?
Because we wanted to test the GUI itself. We wanted to have tests covering the GUI itself. We didn't use the MVP pattern for the logic. Yeah? The project was really small, and the programmer didn't know it too well. It was such a context that we decided to not to use MVP, but we just managed to punch in those tests, and well, yeah, it was a business decision to do it like that. It also works, yeah.
Am I right that without Selenium you can't test only with fitness?
Hmm?
Only with fitness you can't test the presenter. Is it true?
Okay. Only with fitness I can test the presenter.
Without Selenium you can't test.
Yes, yeah. We used fitness both with Selenium because we wanted some tests to go through the GUI and some tests to be executed normally, not using the GUI. So when we would be using Selenium itself, we're just bound to JavaScript and what could be executed in the browser. And when we use fitness, then we can do anything that we want because we have the Java language with us, or C# or any flavor of fitness you choose to use. And you can use Selenium through the Selenium remote control. It's a mechanism for executing Selenium commands remotely. Yeah, and putting those two tools, combining those two tools together is quite well described on many blogs in the internet. So if you just type Selenium with Selenium from fitness or something like that, you get those pages. Yeah, it's Polish, I'm sorry, the comments, so I told you it's a real word thing. But we used English for the DSL. So is fitness, and those are tables that fitness uses to execute tests. This is data for the tables, and those are assertions. I need to scroll. Yeah, no, I need to scroll. So, for example, those are tests not using the GUI. And we created some kind of DSL to so we can make the tests readable for the client. So the client knows what he'll be doing when he'll be clearing reports. So he would like to set the date for today. The report will be done for a user called Anna, and he's looking because he's doing reports for specific days, and he's looking for a date that's November the 20th. So if this is a DSL, yeah, under the hood there's hidden logic that does this command, but the client doesn't want to know what's under the hood. He only wants to say, I choose a report for this day. So we write some piece of code that chooses this, and we show it as a method find or create for day with this parameter, so we can use it in fitness in such a form. So he reads that and he understands that. Yeah? And this is one way of creating a DSL. That's a domain-specific language, so it's created for this client because he knows those words, and for this concrete project. So using this language, we can write tests. Using this language, he can duplicate that and enter some other data and see it run or not. And it's readable for him, and it's readable for us, and it's executable. So it can serve as a documentation. Yeah? It may. When we would start off, then probably those tables would have looked much more, not like this, if we didn't have the code yet, but we would write specs in this form, and then while writing the code, we would adjust the tables to match the code we write. So well, it's changing columns and reorganizing it, but leaving the merits inside. So so we would transform the tables into an executable document, and the client could see yeah, that and execute it. And it's fitness. It's a web server also. So this could be accessible by over the internet, for example, or within an intranet in a company. So there's would be one source of this documentation. Yeah? Yeah, I'm trying not to. It's already late, so I'll go to the part where, yeah, where we write. And those, for example, are the tests using Selenium. So, as you can see, well, they're not much different in fitness. They're not much different than the others, but under the hood, we're executing those, the GUI, and those using the GUI. The DSL is really similar because we hide all the differences in the fixtures. Once you invest some time into writing such fixtures, it's well, you need to spend time on that, but it's not something that we could not afford in a project. This was a 4-week project, for example. So and we afforded to do this. So it's not really
for writing this test for a 4 weeks project. Approximately 10 or 100.
Question, I didn't count that for that project. I think it was around 20. Could be a little more, but no. I think it was around that. Yeah. Previously it took her longer, but now she knows Selenium, now she knows fitness really well, so she is pretty fluent in using that. So that's about, I think, what it took her to do that. Okay, I think I have to move on. I know I didn't say all the things that I wanted to here. And I'm getting a feeling that it's pretty vague what I've just shown, but well, too bad. I can't do any more of that. Now I would like to show a this will be really short because it's not a real world application. We have done this prior to all those two. It was just a proof of concept we have done that we could link fitness with NUnit forms for that project, the first one. So a rich client in C# and tested in that way. And yeah, this is a really simple test for a application, and yeah, that's the test. It's a color mixer, and as you've seen, it puts the first color green, selects a second color red, first color yellow, and checks if it's yellow. Then it puts yellow and blue. Checks if after the mix if it's a green. Yeah? So and it's using NUnit forms to execute that. But as you can see, it's well, slow. It's a simple test, and it's really slow. So imagine now having hundreds of tests like that. That's why we try to do MVP and other things for GUIs, and also having GUI tests, but more of like smoke tests, or touching things that we are really afraid of, but not everything. Just to prove the GUI works, but not to test it thoroughly. And we are not afraid to do that because we have all the logic to test it in the presenter. Yeah.
Maybe I'll share my experience with this approach. I think it can be quite useful when you need to introduce some acceptance tests or unit tests to the team. Well, these tests are easier to write than unit tests for some architecture. So when the team is not mature enough, you can use this approach, because it's really simple to write. You just get access to some text box and enter something to it. It's really easy to write. And the other thing is that it can be useful for testing legacy applications. Just you don't have to refactor the code to write the unit test. You can start with such tests and then refactor, so you can feel safe when refactoring. Anyway, so.
Yeah, so it was true what Krzysiek said, that running tests through GUI feels easier, and it is easier. Writing an MVP and having a good architecture is not easy. You need good object-oriented skills to do that, and open mind how to do that, and that's also our experience, that we have failed to do that in one of the projects. We tried to introduce MVP in particular, the passive view in particular, but we failed to do that because the programmers weren't ready for it. They just didn't know how to do that. The skills weren't there. So I'm gonna skip ahead and I'm gonna talk about the setup, how to set things up. First thing, it's important, and it should be done at the very beginning. So you start from day one using it. Don't postpone that into the third, fourth iteration, or start without it and we're gonna get along, because you will not get along. You will not catch up. It's also our experience that if we start without a continuous integration environment, we end the project without it. So do it before you start the project. And the tools are, well, the most recognized is Cruise Control, or cruisecontrol.net for the .NET environment. We also used Landbuild. I know there are others, like for Maven there's Continuum, and there are many others. Yeah. But setting up the project doesn't mean, well, it also means tools and infrastructure, but it doesn't stop there. Many people stop there. They think project setup is just, well, put this server plug it here and plug this plug there. It's wrong to think that, because you miss many things. You need to, if you use acceptance tests, it's really good to focus your initial phases of the development. That's the requirement specification or requirements elicitation phase. You need to orient it to acceptance criteria. I say criteria because they're not tests yet. You're going to transform them into tests. For example, you could write using fitness such tables, but they're not going to be tests yet because they're not going to be executable because there's nothing to execute them against yet. But what's important is to think of the specification efforts as a way to get the acceptance criteria, the things you're going to need to implement the acceptance tests when you implement the software. It really helps to focus the development on what's important while not getting into some technical details, because in fitness, in those tables, it's really hard to stray and talk about some database, what you're going to use, and triggers or not triggers. It's irrelevant at the beginning of the project, but I've seen many teams talk about that, get into discussion with the client about that. It's a waste of time because it's not a place and time to make that decision. So orienting the requirement specification towards acceptance tests helps to focus on what's important at this part of the project. And as I've shown, I try to show you, it's good to create a DSL to describe the project at the beginning while collecting the acceptance criteria. Try to punch out phrases and common language structures that are used in this domain, so you will be able to implement those acceptance tests using a DSL that will be recognizable by the client, specific for that project, and that will help you communicate. That way the client will feel that those documents are his work also. He will be able to read them and you'll be able to execute them. There will be less communication problems if you use a DSL. And yes, the documentation. Of course, those acceptance tests with using a DSL, they are a form of documentation. So yes, we need documentation. We need it. We've talked about why we need it. Everyone of us has his own feelings about the documentation, and one way of achieving it that we find good is through acceptance tests. But yes, that's not all documentation are acceptance tests. We need, for example, a vision document or some other things that are not acceptance tests. Yes, yeah? But most of the documentation for us should be executable. We strive to make the best part of it executable. So yeah, so what I talk about, if we do that, we set the relationship with the client, our weekly talks, our meetings, based on acceptance tests. When we meet after every iteration, we show running acceptance tests. When the client tells us something's not working well, we say, did you see that in an acceptance test? Is one of the tests failing? No. Okay, then if he's able to do that, maybe he could write a test himself if the DSL is strong enough. Then together with the client, try to formulate his new needs or complaints in forms of acceptance tests. Because that's the way, this way, this communication will be, well, brief, but very concrete. Yeah? This is not working. Okay, so I implement that. Now it's working. Okay, good. And what people miss, well, what I didn't find a lot of people talking about, and it really annoyed me, is contracts. In the Agile community, I rarely find people talking about the problems of how to set the relationship, the legal relationship. Well, I did find people talking about that, but mainly asking questions and not getting useful answers. I mean, I heard once an answer that really pissed me off, that, one of the gurus said that, times and materials are really good. I work like that with my clients. Tell your clients to work like that. Yeah? Okay. If I would write 20 books about that, then maybe I could persuade them to work with me with such a contract. But until that time, I have to use other contracts. So for contracts, we often need some documents. So acceptance tests may be used as specs and acceptance criteria that could be put into a contract. If it's fixed time, fixed scope, those are the different problems how to do that in an Agile environment. I won't go into that. But what I mean is that those acceptance tests could be the specs and the acceptance criteria that are put into the contract that you sign off. Because it's a trap. It is a trap, but for me it's a better trap than signing off a document in Microsoft Word describing vaguely what I need to do and then letting the client hit me in the head with it. So at least here I have some acceptance criteria that are binary. They're either the test passed or they don't pass. So if the client changes his mind, he adds things to the contract, and we have some legal ways of doing that. Okay, and with that, I think we have reached our time. If there are any questions, I don't know if now there's time for them, or later, or in the roundtable discussion, or yeah.
Yeah,
Thank you.